Okay, here's a video with a little more detail on this problem. Here's the arc length formula. L equals the uh, indefinite integral of ds, where ds is one of these two, depending on whether y is a function of x or x is a function of y. In our case, y is a function of x. And I'll give credit for this picture right here. It's from Paul's online notes at Lamar University. But ds is the square root of 1 plus y prime squared dx. So here's y. How do you take the derivative of y? Well, you use the power rule, 3/2 times 2, reduce this exponent by 1, theoretically multiply that by the derivative of the inside, the chain rule, but that would just be a 1. So these two cancel out, and there's the first derivative. But the formula says we want y prime squared. So we'll square each of these factors, 3 squared, and x plus 4 to the 1/2. The quantity squared is just x plus 4. Distribute the 9. There's the first derivative squared. And if we plug that into the formula for ds, we get 9x plus 37. And so the arc length is from 0 to 2 of the square root of 9x plus 37 dx, which is what I showed you right here on Desmos. Looks like it's about 13.4. If you need a little more help on how to actually evaluate that definite integral, it's a u substitution problem. Let u equal 9x plus 37. Du is 9 dx, so that means if we picture putting a 9 here, so we can get du into the problem, we need to put a 1/9 out front. And by the same token, we need to change the limits of integration. When x is 0, this term drops out. We get u is 37. When x is 2, 9 times 2 is 18, plus 37 is 55. Antiderivative of u to the 1/2, raise the exponent by 1, multiply by the reciprocal of the new exponent. There you go. And the Desmos graph, or right here, shows you that this answer conforms to what we got. Just using the Desmos definite integral function. There you go. Hope that cleared things up for you.